So starting the mechanics section of the paper on question 10, we know that I and j are the horizontal, perpendicular and unit vectors. So we know that I is 1 unit in the x direction and j is 1 unit in the y direction. We've got a particle P resting in equilibrium on a smooth horizontal plane, and we've got 3 forces acting on P. So these 3 forces have to add up to 0 if we're in equilibrium. So we know for part A, F1 plus F2 plus F3 is equal to 0. I'm going to write my vectors in column form just to make it a little bit simpler to see what I'm doing for the calculations. So I've got 3c and 4c for F1 plus minus 14, 7 for F2 plus F3 being equal to 0. So that means that F3 has to be equal to 14 minus 3c and minus 7 minus 4c. And I'm going to switch that back back into I and j form as it's asked me to for the question. So F3 is equal to 14 minus 3c I minus 7 plus 4c j. So I've just taken out that factor of minus 1 there. So that gives me my vector for F3. So now F3 is now removed from the system, so it doesn't get involved, and we know that c equals 2. And we want to find the size of the angle between the direction of I and the direction of the resultant force. So we need to find the resultant force. So let's just write out my vectors again. So I know that F1 is equal to 6i plus 8j, because we've now been told that c equals 2, and we had F2 equal to minus 14i plus 7j. So my resultant force is going to be equal to 6 minus 14 is going to be minus 8i, and 8 plus 7, which is plus 15j. So to think about the angle, we want to find the size of the angle between the I and the direction of the resultant force. So let's just think my resultant force is going to be going in this direction. So my resultant force is going to be going something like that. This is my direction of I. So that's the direction that I is going in. So this is the angle here that I want between my vector. So to do that, I'm going to think about what this angle here would be. So I'm going to take this angle alpha, and the angle alpha, I'm going 8 in the I direction and 15 up. So that will give me tan alpha equal to 15 over 8, which gives me alpha equals 61.9 degrees. So I want to be 180 minus that for the angle. So the angle I want, my required angle, is therefore equal to 180 minus that, which is 118.1 degrees. So that's part A and B. We've now applying a mass of P. We've now been told that the mass of P is kilograms, and we want to find the magnitude of the acceleration. So I'm going to look at using Newton's law, F equals ma. This is for part C. We know that my resultant force is going to be the resultant force from here, and to find the resultant force, I've got 8 squared plus 15 squared, and I'm taking the square root of that. That's my resultant force. My mass is m. I don't know what the mass is, but I do know the acceleration, so that's going to be 8.5 times my mass, which is m. So that gives me m equals the root of 289 over 8.5. So m equals 2 kilograms.